Motherboard. The motherboard is the silent organizer of your entire computer. Every single part you'll hear about in this video eventually reports back to this one board. It doesn't make your PC faster by itself, but it sets the limits for how fast everything else is allowed to be. Think of it like a city map. Roads, intersections, traffic rules. If the map is bad, even a Ferrari CPU is stuck in traffic. Those tiny lines you see, they're copper traces carrying data, power, and control signals. The slots, standardized interfaces reserved for your components, and that's why not every CPU fits on every motherboard, different sockets, chipsets, and electrical standards. And that brings us perfectly to the brain that lives right on top of it, CPU. The CPU is where thinking happens. Every click, every app launch, every calculation, the CPU executes instructions for it first. When people say, "My computer feels slow," 9 times out of 10, they're talking about this chip being overloaded or bottlenecked. Modern CPUs don't think once, they multitask using cores and threads. One core can execute one instruction stream, while multiple cores and technologies like simultaneous multi-threading allow many tasks to run in parallel. That's why opening Chrome with 20 tabs can feel smooth on one system and painful on another. But here's the catch. The CPU doesn't remember much. It processes data incredibly fast, then immediately moves on. So it needs help, and that's given by RAM. RAM is your computer's short-term memory. It holds everything your CPU needs immediately and repeatedly. That browser tab you're on? In RAM. That video you paused? RAM. That game you alt-tabbed? Still RAM. More RAM doesn't make your computer smarter, it makes it calmer. Less swapping, fewer freezes, less "why did everything just stop?" And RAM speed matters too. Bandwidth and latency affect how quickly data moves between RAM and CPU. Now, another component apart from RAM that power users obsess upon is graphics card. The GPU is a massively parallel processor built just to handle visuals, pixels, shaders, animations, video encoding, 3D rendering, all of it. If the CPU is the brain, the GPU is the visual cortex. This is why gamers, video editors, and 3D artists obsess over GPUs. A strong graphics card means smoother gameplay, faster renders, and offloading graphical workloads from the CPU. And yes, your CPU can handle graphics on its own using integrated graphics, but asking it to do everything is like asking one employee to run an entire company. Which brings us to where all your data actually lives, which is SSD. An SSD is modern storage, fast, silent, and orders of magnitude quicker than older drives. Apps open faster, files load instantly. Your operating system feels responsive. If you've ever upgraded only to an SSD and thought, "Wow, this feels like a new computer," this is why. SSDs use flash memory, not spinning disks. No seek time, no waiting, just near instant access. But speed isn't everything, which is where comes the hard drive. Hard drives are the old-school storage tanks, slower, mechanical, but cheap and massive, perfect for storing videos, backups, photos, and files you don't need instantly. That's why many systems use both, SSD for speed, hard drive for space. One handles urgency, the other handles volume. Now, all these parts working continuously creates one unavoidable problem, heat, which you have to deal with by cooling, which is provided by a cooling fan. Well, heat is the silent performance killer. Too much of it and your CPU and GPU will throttle, intentionally slowing down to prevent damage. Cooling fans, along with heat sinks, heat pipes, and coolers, move heat away from critical components. More airflow means more stable performance and longer component lifespan. This is why tiny laptops struggle under sustained load and desktops breathe easier. Cooling provides the much-needed consistency. And finally, the most underrated component of all, the one without which a single component cannot work, the power supply. The power supply unit, or PSU, is the heart of your system. It converts raw AC electricity from the wall into clean, regulated DC power that your components can safely use. A bad PSU doesn't just fail, it can damage everything connected to it, even cause a fire. A good PSU, you never notice it, and that's exactly the point. It helps everything else do their job while itself sitting silently. And now, just like that, you understand every major computer component, not as a list, but as a system. If this made computers finally click for you, you'll love the next one. Tap the end screen to watch every DDR RAM explained in 4 minutes. It'll instantly upgrade how you understand RAM, which I explained earlier. And if this helped, hit like, subscribe, and I'll see you in the next one.